The next presentation will be given by Chris Jones, our chief race judge. It's on the importance of battery connections in the solar car battery box. I know that we've had a lot of experiences with certain overheating of batteries or even battery fires, and Chris is going to talk about why it's important to have proper connections that's tightened down. So, Chris?
Thank you, William. This presentation, it was originally done by Jarrett Dunn, another one of our foundation board members. I'm shamelessly repurposing it, rebranding it more, and going to represent it to you guys again. So really, this is going to be electrical safety in general. I'll talk about it more tomorrow, and a little bit about battery boxes, specific emphasis there. So why do you care about this? So this is the Nunya Solar Car. For the World Solar Car Challenge, let's just look at a time lapse. Lithium battery pack. The driver got out, nobody was hurt in it, but that's all that was left of the car after the fire. Here's another one. This is, again, World Solar Challenge. This is Stanford. They managed to get their battery pack out in time, which, you know, the other team wasn't quite so lucky. This is us. In 2018, we had a fire in the Palmdale battery pack. 2018, All Saints melted a battery terminal. 2019, this is the Rocketeers fire. The pictures here understate this a little bit because what really has happened here is you can't see quite how much of the inside of the battery box is burned out. And we also had another team, Energy Odyssey, lose their main power in 2019. 2020, 2020 we didn't race. 2021, last year, we changed the policy a little bit on this and are working some things out. But I mean, this is legitimately after a fire was put out on a car on our track. And none of this had to happen. We'll talk a little bit more about the lithium packs. They're their own kind of beast, but this didn't have to happen to any of these teams listed here. Right now, I'm going to show you how you start one of these fires. Let's see if I can make this work. Can you see how easy that is to move right there? I don't know. So for some of the new teams, your basic math, as resistance goes up because you have a poor connection, the energy has to go somewhere. The energy turns into heat. All of this gets rapidly very hot. You'll burn up the insulation. You'll start melting the terminal. Eventually, you'll catch the top of the battery on fire. I'm going to come, well, I don't know how to, I'm going to stop sharing for just a second because I want to, I'm blurring my screen because I want to just show you guys some stuff here. Choose virtual background. I'm going to turn this off for a minute. You guys can see the back of my office and maybe my kids running in here. A couple of things. The reason why you don't have so much problem with this is normally on cars, you're used to seeing a nice connector like this. You got a soft lead post that'll go through here. You crank down the bolt on it. It holds itself on there and no issues whatsoever. For most of your applications on solar cars, though, you simply have a nut and bolt type situation here where, you know, this is going to be able to free spin. The only thing that keeps this nut from moving is that when you load it, it deforms the threads and it sticks. But if things get hot because a connection got loose or vibration, which by the way, vibration is the #1 killer of all nuts and bolts, it loses its preload and it just comes loose and you can free spin it like it is on your hand. That's why when we go back to seeing this, it's such an issue that we have here. What's happened in this video is even though that nut was tightened at one point, there's nothing keeping it tight on there. And that's the serious danger. So we instituted this in the 21 race, and going forward, we're going to be checking daily on battery box terminal connections. And if you have lithium ion, we'll look at whatever the relevant connection is for that. Yeah, sorry, here's the how to start a fire prompt. Here's some of the things that are pointed out on the battery data sheets. It will usually call out a specific amount of torque that you want to torque them to. This is if you've got a bolt going into a soft aluminum post. That doesn't mean crank it for all it's worth. And I don't know if you guys can still see this. Okay, this is a standard torque wrench. It's good to learn how to use these for when things do call out standard torque. But since most battery posts are soft lead, you want to get them tight, but you don't want to get them so tight that you just strip out all the soft lead threads. So if you look in your battery data sheets, it'll tell you for those types of posts what to do. The other thing is, this is the new thing that we've kind of instituted and come to realize. There's 3 types of washers shown here. Here's a standard split washer or lock washer. These are real easy to slip in there between 2 regular washers. And what it'll do is, because it's springy, it holds the tension on that nut so it can't back off. You know, we've all used lock washers on things before. They keep it from coming undone is the end of the story. Shown here is a side view of a Bellevue washer, Belleville washer, can't talk. Those work the same way, but instead of splitting down the 2 pieces so that they're flat, this one is kind of the center pops down until it's flat. The other thing is, I learned about these a couple years ago when Jarrett did this presentation. These Nordlock washers are pretty freaking amazing and kind of ideal for this. You can find them on the internet. They're just actually a really good lock washer for any mechanical fastener.
Chris,
choose your best practice.
There's a question online.
Sure.
What materials would be best to insulate the box in order to prevent a fire?
So it's not insulating your box that's going to help you prevent a fire. Yes, you don't want to have your box, say, be aluminum and have a bunch of batteries right next to it, so you accidentally short them out, getting them in there, or putting a wrench in there or something like that. So you want to put something non-conductive in there, and I've seen a lot of different types of foams, or I've seen people build the interiors out of Lexan polycarbonate, that kind of thing. But there isn't really a specific insulation for the battery box. What you need to do to prevent your battery box fires, the most common cause, is prevent there from being something loose in the battery box. This is what does it. You have a loose, high resistance connection that gets hot. I guarantee you that you're not going to have much of an issue. I can't guarantee absolutely, but 99.9% of the problems go away if you've got the terminals locked down and they stay tight, meaning good connections. You can still have a fluke thing in a battery, but that's kind of a 1 in a million thing. You could have internal damage to battery or something like that that could cause a fire. Same reason that automotive batteries on very rare occasions can explode when you're charging them or things like that. But we're not talking about that. We're talking about how this happens so often at the event. So please ask again if I didn't answer the question properly for you, but it really is keeping fasteners tight in there. It's not like something is touching that's causing a short that causes the fire. This is loose connections getting hot. Let's get back over to this. So best practices for this, and William, please feel free to interrupt me again. Just checking torque. You want to make sure those bolts stay tight. And often, sometimes a simple wiggle test will do. That's typically what we're doing. We're not necessarily asking you to put a wrench to it and crank on it. There's rechecking the torque. And these are Jarrett's notes. Just kind of establishing a schedule, remembering to do it. You have to keep remembering to recheck the torque, because your cars are going to bounce around on the road and vibration will loosen things everywhere on the car. That's why we have all the rules about critical points in suspension, having to have them Loctited or lock nutted. Indicators. So I work in the aerospace industry, specifically on space. We do this for fasteners that we lock down too. There are really cool, colorful commercial compounds you can get that you can basically, they dry like low strength epoxy that you put a little dab on the nut and the bolt. And if it breaks, you can tell that the connection actually broke and the nut worked loose. Most people do it on the cheap and just cheat using nail polish. That works just as good. Likewise, you can use just a little dab of epoxy on there because you can always still break that loose with a wrench. Oh, okay. So I'm rereading the question here. What materials would be taboo to use as a battery box? Wood is a safe choice. We see that a lot. Personally, for the weight trade-offs, I like polycarbonate or even some lighter insulating foams. You can actually find some of that stuff on Home Depot, tons of it on the internet. It just has to be non-conductive. But yeah, quite a few teams use wood. Again, it's just not my first choice because it's kind of heavy, although I know it's easy to work with. Battery boxes are pretty simple. I really would recommend, even to new teams, looking into like polycarbonate or just some non-conductive foam you can get from McMaster-Carr or some other place like that. Sorry, Michael, hopefully that better answered your question. General safety concerns, we're going to veer a little bit from this, but everything has to be properly sized, neatly secured. You wouldn't want to run your propulsion batteries on 12 gauge or 14 gauge wire. You'll just instantly burn them up because they're not capable of handling that amount of current. There are lots of different guides out there that can tell you voltage drop, what current, what size of cable is rated for, and for how long. One thing that I believe is important to remember on that, I'll talk about more of this in the electrical presentation, is solar cars aren't continuous use. You're not running this much current through it 24/7. You're on and off as you get going, which tends to mean that you can actually be a little conservative with a table, or maybe the right word is liberal, I don't know. You can tend to use slightly smaller gauges than what's recommended there sometimes because it's an intermittent current. I'm not always pulling full load on my motor, kind of a thing. And actually, you're more than welcome to talk to us and talk to your other experts. Typically, I've seen that either 4 or 2 gauge wires been sufficient for just about every propulsion system we've seen here. I've never seen somebody need 0 gauge wire for the current that they're carrying. And you guys will find out more about that when we talk electrical. Let's talk best practices. I have no idea where Jarrett got this photo, but it's pretty freaking amazing because I see a lot of solar cars that basically look like this. You got wires everywhere, colors mixed around. You did it in a rush. I know you were out of time when you put it in there, but this is just a disaster waiting to happen. And oftentimes, I'll see the teams that are in a rush doing this in their cockpit for around the driver, lots of things that can snag on. I will stop you at scrutineering. The judges will stop you, make you go back and neaten it up. I mean, this is really kind of what you want to strive for. Taking a little bit of extra time, like you've already heard today, with doing labels, doing color coding, having a good wiring diagram means that when you need to go troubleshoot, everything gets a whole lot easier. And again, I speak from personal experience. We rushed the job back in 97. And I think in 98, it was only maybe in 99 when I finally took a little bit more time with it. And I remember having a turn signal issue and spending the better part of 8 hours in the middle of the night trying to fix it so that we could get the car going on the road the next day. That was right before scrutineering started, before the rules were the way they were. But anyways, lithium safety, the main takeaway that I want from this, and you guys can all Google Google lithium battery fire on, or go search it on YouTube. And there's plenty of very frightening things you're going to find out. Basically, it comes down to oftentimes being an overcharge issue. So the very first thing is be prepared for your battery chemistry. Whatever chemistry of lithium you're using, make sure you have the right type of fire protection equipment on your car, in your support vehicles, so that you can do something about it if a pack is on fire. And by the way, if your lithium pack is on fire, the driver needs to just get the heck away. You don't want to be breathing that stuff. But you should, nearby in a support vehicle, have what it would take to put out the fire. We require monitoring at the cell level because it only takes one cell to go over voltage, to get overheated and start blowing up, and then spontaneously combust. So the absolute minimum is having over voltage protection at the cell level. And what we'd be looking for ideally, and what we'd be recommending you get with your lithium system, is making sure that you have both or all over voltage, a temperature monitoring, and even some overcurrent protection on there. That's going to give you the safest lithium pack you can have. And I know I'm just touching at a very high level on this stuff, but these were some of the takeaways from, again, a very high level. I think that's all that I've got, unless there's more questions about this. I was trying to keep it a little short, and I actually, hey, ended on time. That's a first for me.
Thanks, Chris. I think the other thing about lithium batteries, as you heard from Joel's presentation, was that under voltage is almost as important as over voltage in the
Yes.
sense of by pulling out too much out of the battery, you could also trigger some heat and a fire as well.
Thank you.